Hey guys, welcome to question FM266 of the Further Maths Fortify study guide. This question reads, the directed graph below shows the sequence of activities required to complete a project. All times are in days. This question asks us, or tells us, there is one critical path for this project. It then asks us, three critical paths would exist if the duration of activity, and then we're given 5 options as to what we could do to create 3 critical paths. So what we're first going to do is a forward and backwards scan of this network for this project, because we want to see what our potential 3 critical paths could be, as well as understanding where our critical path is at the moment. So starting with A is going to have an earlier starting time of 0 days. A will take 7 days, so B has an early starting time of 7, as does C. After B starts, if B was to start on the 7th day and take 7 days, that means that we're going to have earlier starting times for D and E of 14. F and G are going to have earlier starting times of 10. Moving over to H and J, they're both going to have earlier starting times of 16. From here, I and L will have earlier starting times of 11 and 11. And K is going to have an earlier starting time. Well, it's going to be between the 4 connections that are coming into it here. So we're either going to have an earlier starting time of H starting at 16, taking 2 days is going to be 18. Coming from E is also 14 and then 4 days, another 18. G being 10 and 3 is going to be 13. And I with 11, starting at 11 and taking 9 days is going to be an early starting time of 20. So of course we take the biggest of those numbers, the 20. And then for our final little bit here, coming into the finishing end of the project, we have 3 options, so either early starting time of 11 for L and 5 days, so an early starting time of 16. Early starting time of 16 for J and taking 3 days is 19, so we've got completion times of 16 and 19. And then K, starting on day 20, taking 5 days is 25. Once again, we take the biggest number there, that 25, and that is the earliest completion time of the project. Now doing the backward part of our scan, 25 take 5 for K is going to leave us with 20. 25 take 5 for L is also going to leave us with 20. And 25 take 3 for J is going to leave us with 22. Moving backwards from here, from K, so we've got a later starting time of 20. So for I with a duration of 9, later starting time of 11. For H with a duration of 2, later starting time of 18. For E with a duration of 4, later starting time of 16. For G with a duration of 3, its later starting time is going to be 17. From here we'll do F. So F is either coming off of L or I, so a later starting time with L of 20, take 1 would be 19, but for I with a later starting time of 11, that would make its later starting time 10, so the choice between 19 or 10. And when we're doing our backward scan, we take the smaller numbers for the later starting time, so it's going to be 10 here. Activity D is going to have a later starting time either between duration of 2, it's either going to be 20 or it's going to be 16, we take the smaller. Moving back to B, we're going to be moving back from 16, subtracting 7 from 16 in both cases. So in both cases, it's 9. Our C is going to be working backwards from not G, but F, which gives us a later starting time of 7. And A, of course, is going to have a later starting time of 0. So now that we have this information, we can figure out where our critical path is, and by looking at the activities that have the same earlier starting time and later starting time. So we can see that our critical path moves along here. Now, what we're looking for when we're trying to figure out where the other two potential critical paths could be is two paths that have the same float time at the moment, potentially. So that looks pretty promising in that if we look at the float times of each of these other activities, L has a float time of 9, G has a float time of 17, J has a float time of 6, but then H, D, E, and B all have a float time of 2. So our potential other two paths, or two critical paths that would be joined in, would be up along the H through D and B, and from E through B along there, because they have a float time of 2, whereas the other potential pathways have float times of 6 and upwards. So we're looking for, when we're looking through our options, we're looking to probably reduce our current critical path by 2 days, anywhere beyond A, and we're given that option in option C, which says that if we were to reduce, that we have the option to reduce I by 2 days. So if we were to reduce I by 2 days, the 2 days worth of float time along each of these other two potential paths would catch up, and we would end up having 3 critical paths in this form along here. Now this question is really hard to get if you haven't practiced a lot of crashing before in these types of networks, so don't be too stressed out if you don't get this one straight away. Keep playing with them, looking at the numbers and playing with those. If you would like any questions answered, please drop them in the comments below. Otherwise, I'll see you in the next video.